Hello, my name is Meredith Ringel Morris from Microsoft Research, and I wanted to give a brief talk for the CVPR workshop on the topic of combining human and machine intelligence to describe images to people with visual impairments. Digital imagery pervades modern life. More than 1 billion images per day are produced and uploaded to social media sites, and we also encounter digital content, images within websites, apps, digital documents, and ebooks. Engaging with digital imagery is part of the fabric of participating in contemporary society, including education, the professions, e-commerce, civic participation, entertainment, and social interactions. However, most digital images remain inaccessible to the 39 million people worldwide who are blind. People who are blind access their computer using screen readers, which are software that read the contents of the screen out loud. This works fine for text, but when a screen reader encounters an image, it either skips it or just announces image, unless the content author has provided a caption for that image. HTML and other digital document formats usually support the addition of alternative text, which is also called alt text for images. If the content author provides an alt attribute, then a screen reader will read that caption aloud. In this example, this is a photo of when I happened to run into members of the Harlem Globetrotters basketball team that I posted to my website. And as a diligent author of accessible HTML, you can see that I added the alt attribute to the image tag, and my alt text that will be read by the screen reader says, "A short researcher stands between two very tall members of the Harlem Globetrotters basketball team." Unfortunately, compliance in providing alternative text for images is low. About half of images on popular sites lack alt text. Images with alt text often have poor quality captions, for example, just saying image or giving a file name. This can be due to efforts for search engine optimization in which sites that actually have some content, whether or not it's quality versus garbage content, are more likely to appear higher in the search engine results. People may also use the alt text field to put in keywords unrelated to the image with the hope that that will help their web page show up in certain kinds of search results. Newer media like mobile apps and social platforms may not even support the alt attribute at all. For example, Twitter lacked alt text until 2016. One way to scale including alt text for more images is with AI. Recent breakthroughs in deep learning have led to advances in computer vision. For example, in 2016, Facebook added an automated alt text feature, which uses tags rather than full natural language captions in order to be a little bit more conservative in describing the images. In Facebook's CSCW 2017 paper, they describe how they only apply tags to an image when they have extremely high confidence. This is a really good start, but it doesn't provide the same kind of quality as a good human description. Microsoft Office now does something similar with images in PowerPoint documents. So in this example, we see a Facebook feed that describes an image for a screen reader user. It says, image may contain two people smiling, sunglasses, sky, outdoors, water. This description is better than nothing, but doesn't really get at some of the key attributes of the image, such as who are the two people? Where are they? What are they doing? What makes this a particularly interesting image that someone would share on Facebook? Based on vision to language technology that Fong et al. Presented at CVPR 2015, Microsoft released a website several years ago called CaptionBot.ai. So I tried uploading to CaptionBot.ai that same photo from my website of me with the Harlem Globetrotters, and the system said, I think it's a group of people standing in a room, and they seem happy. Well, technically that is correct. We are a group of people standing in a room, and I'm certainly happy. But again, this is really not a particularly informative image description. It misses the most interesting part of this image, which is that the Harlem Globetrotters are there. They're famous celebrities. They're super tall. They're wearing basketball uniforms. They're doing that move where they spin the basketball on their fingertip. None of that information is present in the AI caption. And of course, this was an example where the caption was technically correct, but sometimes these automated systems may even make more explicit errors. With my colleagues, former intern Haley McLeod and my colleague Ed Cutrell, we conducted a study a couple of years ago in order to better understand how people who are blind consume captions generated by AI systems. So we began first by interviewing 6 experienced blind users of Twitter about their experiences with image captions in their Twitter feed. And then we conducted an online experiment with a larger set of 100 blind Twitter users in which they consumed a Twitter feed that had a mix of correct and incorrect automated captions for the images accompanying tweets in order to understand their trust in the AI system, even when it was blatantly incorrect. So first, in the contextual inquiry, we created a Twitter feed of approximately 100 tweets that were tweets taken from popular accounts at the time, covering a range of topics, including humor and memes, news, social posts like selfies, etc. And then we used at the time what was a state-of-the-art vision-to-language algorithm to create the alternative text to describe those images. And so we sat with participants while they consumed this Twitter feed on their screen reader, and we asked them to talk aloud about each of these tweets and accompanying images as they encountered them to tell us about the quality of the descriptions. And beforehand, we emphasized to the participants that these descriptions were generated by a brand new AI system that was still making a lot of mistakes and that still needed a lot of work. But even though we emphasized to participants the high possibility of error from the AI system, we found that people were overly trusting of the captions. So this is an example of a tweet from the feed that we used. And so in this case, the participant would hear the tweet itself read aloud by the screen reader. So they would hear that Whole Foods Market tweeted, "Ready for hashtag summer entertaining? Plan with special diets in mind, hashtag gluten-free." And then in this case, we can see that there's a picture of some kind of pasta with vegetables in it. And what they would hear was the AI system's description of the picture. So in this case, they heard, "I think it's a plate of pasta and broccoli," which seems mostly correct. I think the vegetable actually looks more like basil than broccoli, but it's pretty close. There's a green vegetable. So that was an example of one of the good captions. Here is an example of one of the incorrect captions. So the participant would have heard, as you can tell, this was right before the US election in 2016. So the participant would have heard, "Hillary Clinton tweets, 'Some on the other side may say our best days are behind us. Let's prove them wrong.'" And then again, they would have heard the AI system's description of this image. Now, if you can see the image, you can see it's a picture of Hillary getting on stage at a campaign rally. But what the AI system says is, "I'm not really confident, but I think it's a man doing a trick on a skateboard at night." And in our case, about half of the captions that the AI system provided were pretty good and made a lot of sense in relation to the text of the tweet, like the Whole Foods example. And about half of the captions didn't make any sense, really, with respect to the tweet itself. And one would hope that even if you couldn't see the image, you would realize this incongruence and be more skeptical of the output of the AI system. We found instead was that the blind participants would make up complex rationalizations for why all of the AI captions, including the unusual ones, must be correct. So for example, in the Hillary Clinton case, one participant said, "Well, maybe Hillary is tweeting this picture of an old man on a skateboard because Hillary wants to appeal to young, hip voters and show how cool she is." And someone else said, "Oh," after we explained to them that it was an image of a campaign rally, they said, "Oh, I would have actually retweeted it, thinking that it was a photo of a skateboarder and not realizing that it was a political image in support of Hillary Clinton." As another example, in this one, the New York Times tweeted a headline, "Why isn't Italy kinder to gays?" And then it has this picture that looks like a photoshopped image of 2 statues of David being very cozy with each other. But what the AI system says about the image is, "I'm not really confident, but I think it's a person holding a tennis racket." And again, participants would rationalize this strange image description. They would say, oh, well, maybe the New York Times wrote an article about a gay tennis player, and this tweet would make more sense if I knew more about gay tennis players. Someone else, again, had this rationalization like, oh, this must be such an interesting article if it's about, gay rights and tennis combined with each other. One participant, after we explained what some of the images really were, reflected on the rationalizations they had made, saying, well, I have to trust the AI captions because I don't have any form of reference. Unless someone cited were explaining it to me, I would have to trust it. Another participant described how confident they felt that the AI captions were accurate, even though many of them didn't make sense, and we repeatedly emphasized that the AI system makes mistakes. So these findings intrigued us to try to collect data from a larger group of people. So we did an online experiment with 100 experienced blind users of Twitter. And in this experiment, we wanted to think about whether we could encourage consumers of these AI captions to be more skeptical of them. So here we looked at the idea of framing effects. So in psychology, there's a well-known phenomenon. For example, if a doctor were to tell a patient, if you get this treatment, you have a 5% chance of dying, versus if they use a more positive framing, if you get this treatment, you have a 95% chance of surviving. Now, mathematically, those two statements are equivalent, but psychologically, people react very different to them. They're more likely to get the surgery if you emphasize the chance of survival, and more likely to choose against the surgery if you emphasize the probability of dying. So we wanted to see if framing effects might impact how blind consumers of captions trust the AI. So in this case, we had 4 different framings of the way the AI system presented the image captions. In the positive framing, the system might say, I'm really confident it's a picture of a cat sitting next to a window. And in the negative framing, the system might say, there's a small chance that I'm wrong, but I think it's a cat sitting next to a window. And we also looked at numerical framings that either emphasize the probability of correctness versus error. So there's an 80% chance that it's a picture of a cat sitting next to the window, or there's a 20% chance that I'm wrong, but I think it's a picture of a cat sitting next to a window. And so participants were randomly assigned to one of these 4 conditions for each image that they consumed. And again, at the beginning of the experiment, they were reminded that the systems were generated by a brand new kind of AI system that frequently made mistakes. And after consuming each tweet and caption, they would rate how accurate they thought the AI caption was. And again, as in our earlier examples, about half of the captions we would expect people to think were accurate if they couldn't see the image because they aligned with the content of the tweet itself. So this is an example where a Lens on America posts, share your best wildlife photo from a national park, #YourShot. And in this case, they've shared a photo of otters swimming in the water. The AI system makes a mistake. The AI system says there's a 25% chance this is a photo of a bear swimming in the water. But we wouldn't expect the screen reader user to be able to know that it was a bear rather than an otter. Rather, we would expect them to trust this caption because the AI system is describing something that is relevant to the topic of the tweet. However, what we would hope is that users would be more skeptical of highly incongruent captions like this one. So in this case, the Seattle Police Department tweeted a headline, "Bank robber arrested after abandoning pants," and they accompanied it with a humorous drawing of a man who lacks pants. But the AI system says there's a 5% chance that's a person on a surfboard in a skate park. So I mean, that caption is already just internally inconsistent because why would someone be on a surfboard in a skate park? But also it has nothing to do with bank robbers or lack of pants. So we would hope that they would mark this as a not trustworthy caption. What we found was that people who received the negatively framed captions were more appropriately skeptical of the AI system. So these were the captions that emphasized the probability that the AI system might be making an error. And whether we framed that numerically or with natural language didn't really have any impact on users' judgments. Therefore, we actually recommend that automatically generated captions intended for consumption by screen reader users should be phrased in a way that reinforces the possibility that the caption might be wrong. So from that study, we saw that perhaps AI systems still make enough mistakes and screen reader users are unable to use their own senses to verify the accuracy of these systems, which can lead to overtrust in the systems. So while AI systems are still in the state of developing to the point where their error rate is low enough to be usable by this audience, one thing to think about is the role of human-in-the-loop systems in providing image captions. And so in this work with intern Elliot Salisbury and my colleague from Microsoft Research, H.A. Kamar, that was presented at HComp 2 years ago, we studied the use of a crowdsourcing tool to help understand better what details might be most useful to include in social media image captions for people who are blind and screen reader users. And so what we did in this work was we developed a system for Mechanical Turk called Tweet Talk. And again, we used the same set of 100 tweets as in the prior work, where these tweets had images and the images had accompanying AI descriptions, about half of which were good quality and half of which were a poor quality. And we paired people who could see the image with someone who couldn't see the image, and had the person who couldn't see the image ask questions until they felt confident that they could describe the image to someone else, and then they wrote a description. And then we had other sets of online workers see the original tweet and image and see the written description and rate the quality of the description. And we looked at and analyzed all of these responses in order to come up with a schema for how to describe images. Now, you'll note that in this case, we had people participating who were sighted but just couldn't see the image. And that's in part due to accessibility issues that make Mechanical Turk difficult to use for screen reader users. So we also ran the study additionally with 7 participants who were blind using a separate interface that we created as a workaround to the Turk accessibility issues. And we found that the details requested by the 7 blind users were extremely similar to the details requested by the Mechanical Turk workers who couldn't see the image. So we combined those different data sources together in our study. And what we see here are some of the results about the categories of details that participants asked about the images. For example, describing the location where the picture was taken, or asking about what kinds of actions were happening in the image, or asking whether there was any text in the image that should be read aloud. And so based on this, we developed a set of 8 questions that captured all of these common themes. And these 8 questions could be used by either human-in-the-loop systems or to collect training data that collects the kinds of details that most interest people, that can then train future AI systems to produce better image captions for people who cannot see an image. So the 8 questions, first was, who are the main subjects of the image? Describe their physical characteristics. Second, where is this image set? Describe the location and the prominent features of the background. Third, what are the subjects of the image doing? Describe their actions and intent. Fourth, what emotion does this image evoke, or what are the emotions of the people present in the image? Next, describe any noteworthy aspects of the image's visual style. Then, is the tweet and image intended to be humorous? If so, explain how. Is this a famous or a well-known image? And is this a meme? And if so, describe what the meme is about. Now, some of these questions may be useful for images from venues other than social media, but some, such as the questions about memes, may not be appropriate for all venues, and generating a list of questions like this to help construct a very detailed alternative text for other kinds of media might be useful future work. Then we used this set of structured questions to have crowd workers author new captions for the images in the Twitter feed, and found that the captions generated through this method were rated much more highly than the original. So in summary, billions of digital images lack captions for people who are visually impaired. Automated systems for creating captions have promise, but they're not quite ready for prime time yet. We need to really improve their accuracy and also improve the level and types of detail that these automated captions include, and we need to express uncertainty to the end user more clearly so that they can decide whether to trust the system. Crowd-powered methods for adding this kind of detail or alternative text have promise, but won't scale to the billions of digital images online. So we need to think about how we can leverage human-in-the-loop methods in order to bootstrap the creation of more automated systems. I want to particularly thank all of my collaborators at Microsoft Research and our interns who contributed to this work. And on the slide, I'd like to point you to my website, aka.ms/MERRIE, where you can download all of the research publications that I referred to in this talk. And I'm looking forward to discussing this work more with you in the Q&A panel during the CVPR workshop. Thank you.